Lesson 2.1, Conditional Statements. Conditional statements usually have an if-then implication. For example, advertisement is like that a lot. If you don't eat McDonald's, then you are not loving it. There are other advertisements that yield the same thing. Your parents might give you a conditional statement. If you don't clean your room, then you can't go out with your friends. The essential question, what is a conditional statement and how does it apply to definitions in geometry? Let's take a minute to set up your notes. There should be a heading, an essential question, and you can see there are a number of vocabulary words. I've left spaces for the description and even an example if you need it. Let's start. A hypothesis can be either true or false. The same is true of a conclusion. We'll talk about what those words are. Determine whether each conditional statement is true or false. Notice that all of them are if-then statements. If yesterday was Wednesday, then today is Thursday. I would say most of us would say yes, that makes sense. If an angle is acute, then its measure is 30 degrees. Now, we know that we know what acute means, but that doesn't necessarily mean it has to be 30 degrees. So with a counterexample that we learned in the last unit, we can say, no, that's not necessarily true. If you have an acute angle, it could have been 17 degrees or some other measure. So that sentence doesn't make sense. Next one, if a month has 30 days, then it is June. Now, there are other months that have 30 days, and there's a very common joke that says, you know, every month has 30 days. Even the ones that have 31 have 30 days. They just have an extra one of that. So that is not a true statement. We're going to be talking about whether statements are true or false. Okay, let's go ahead and start conditional statement. This is our vocabulary word, and a conditional statement is a statement in if-then form. The if part is called the hypothesis, and the then part is called the conclusion. So that's what you'd want to write in your lesson. You'd also want to write a short version form, which is this, where P stands for some words and Q stands for some words. And in mathematics, we can write it this way, where we have an arrow. We say P implies Q, and that's an equivalent way of saying if P, then Q. All right, let's take a look at these sentences and see if we can identify the hypothesis and identify the conclusion. The hypothesis is in red, and hypothesis is always the subject of the sentence. And let's go to blue. The rest of the sentence is the conclusion. Now, how would I write this in an if-then statement? The way I would write it in an if-then statement is I would say, if an animal is a bird, then it has feathers. Now you notice that I had to add some words to make the English sound fine. Okay, let's go ahead and take a look at this next one. In this next one, I want to identify the hypothesis, and again, here's the word if, so there's a clue. Sometimes we put the hypothesis at the end of the sentence, so this is the hypothesis, and then the conclusion is the rest of the sentence. Now let's see how we're going to write that in if-then form. So, if you live in Houston, then you live in Texas. I said live, you could say are in as well. All right, use red to identify the hypothesis and blue to identify the conclusion. It would be a good idea if you stop the screencast right now, try these on your own, and then resume this screencast when you think you have the answer. All right, so the hypothesis is always the subject of the sentence, which is this, and then the conclusion is the rest of the sentence. So let's go ahead and write the if-then statement. And the if-then statement would be, if an angle is 30 degrees, then it is an acute angle. right, next one. The beginning of the sentence is this. Oh, that should be in red. Let me undo that. So the hypothesis is this, and then the conclusion is this. So let's go ahead and write that. And we'll say if 2x plus 7 equals 1, then x is equal to negative 3. All right, let's talk about negation. Negation of a statement is the opposite of the original statement. So in your notes, take a while to put the definition of a negation. Also, take a minute to write it in symbols, in words, and then this is the symbol. So this little squiggly is pronounced not. Okay, so let's write the negation of each of these statements. And the negation will be the ball is not red. So we're taking the negation. Now for the next sentence, it already says the word not, so the negation would be actually the opposite of it. So we would say the cat is black. So if it doesn't have a not, you put the not in, and if it already has it, you take it out, and that will be the negation. Okay, there's going to be some important words in here. One of the words that we've been talking about is conditional. So conditional, and these are the words, and this is the symbol. Here's a mathematical example. If x is equal to 2, then x squared is equal to 4. Our next vocabulary word is converse. Take a minute to write the words, and then take a minute to write the symbol. And here's an example. Notice all I did was exchange the hypothesis and conclusion. So this and this have been reversed. Notice that this now is here and this is now in here. Our next vocabulary word is inverse. The inverse negates both the hypothesis and the conclusion. So I'm going to take this statement right here and I'm going to negate it. So since it says equals, I'm going to write not equals. And since it says equals 4, I'm going to say not equals. And take a minute to write the words. Take a minute to write the symbols. Our last vocabulary word is contrapositive. And a contrapositive in words looks like this. And in symbols it looks like this. So really what it is exchanging the place right here. So you're taking the inverse and you're exchanging the places there. Or you can just think of it going back up to the very beginning, right here. And what we do is we negate both of them and then exchange both of them. Now, equivalent statements are statements that are both true or both false. So, for instance, this is a true statement. True. Now, this is a false statement. Now, why is it false? Because x could have been negative 2 as well. Now this one, x does not equal to 2, then x squared does not equal to 4. That's false because a number that does work is negative 2. So we would call these two equivalent statements because they're both false. If x does not equal to 4, then x cannot be equal to 2. That's a true statement. So since these are both true, we say that these are equivalent statements. Okay, let's see if we recognize the symbols and what to do with them. P is you are a guitar player. Let's go ahead and redo that one. You are a guitar player. And Q is you are a musician. All right, so let me go ahead and write the answer. So I want the conditional statement, which is an if-then statement. If you are a guitar player, then you are a musician. For the converse, remember we're switching places. If you are a musician, then you are a guitar player. For the inverse, remember that we are negating the conditional statement. If you are not a guitar player, then you are not a musician. Contrapositive, you take the original statement and negate them both, just like we did in the inverse, and then exchange places. If you are not a musician, then you are not a guitar player. Now it also asks us to determine whether these are true or false. So if you're a guitar player, then you're a musician. I think you would agree that's a true statement. If you are a musician, then you're a guitar player, and that's false, and that's because I can give you a counter example, and you could be a drummer. Okay, if you are not a guitar player, then you are not a musician. That is also false. We can use the drummer as an example as well. If you are not a musician, then you are not a guitar player, and that's true. You're not a musician, there's no way you could be a guitar player. So these two are equivalent statements because they're both true, and these are equivalent statements right here, these two, because they're both false. All right, biconditional statement. A biconditional statement is when a conditional statement and its converse are both true. You can write them as a single biconditional statement. Now here is the vocabulary word, which you need to go to your notes. You need to write the words and you need to write the symbols. Now here's an example of what they're talking about. This is a conditional statement. Conditional statement. Notice it has a hypothesis and a conclusion, and that is a true statement. Now here is the converse, and notice I switched places right here, and this is also a true statement. So they're both true, the conditional and the converse. Now when we have this, we can kind of merge these two sentences into one. What we do is we take the phrase, put one phrase in the front and one phrase in the bottom, and then we join them together with the phrase if and only if. Now this is a good way to write a biconditional. You can also write the phrases in a different way. You can have this other one in the front and this one in the back, and again joining them with the if and only if. Notice that neither biconditional starts with if. The if and only if are in the middle. Okay, so in definitions, we should be able to write a definition as a biconditional. So both the conditional and its converse will be true. So let me go ahead and take this definition and rewrite it in if-then form. So if two lines form a right angle, then they are perpendicular. If, oops, too big. If two lines are perpendicular, then they form a right angle. Now the first one is the conditional, the second one is the conditional. We can pull them together and put the phrases at one end and the other, and the in-between phrasing will be if and only if. Two lines are perpendicular if and only if they form a right angle. Okay, so this is what they were asking for. They were asking for the biconditional. How do I know that's a biconditional? It has this phrase, if and only if. And it stands for these two sentences, the conditional and the converse. So it's a shorthand notation of writing two sentences. Okay, and here we have another opportunity for you to take a definition and write it as a biconditional. Stop the screencast, see if you can write it, and then resume. Okay, so the answer will be, one phrase is an angle is a right angle if and only if it measures 90 degrees. Again, the phrase if and only if has to be there. Okay, so our last example is, can you take a phrase and write it in all of the ways, the conditional statement, the converse, the inverse, and the contrapositive. So one more time, stop the screencast, see if you can write all 4 statements, and then resume. Okay, so the conditional statement will be, if snow is falling, then it is winter. And that's a conditional statement. If we reverse it, if it is winter, then snow is falling. That's an example of a converse. Notice I switched locations. Okay, and then the inverse of the original, if snow is not falling, then it is not winter. And this is an example of an inverse. If it is not winter, then snow is not falling. Oops. Snow is not falling is an example of a contrapositive. Okay, and this ends the lesson.